Can't talk today. All right, so we are on lesson 24. This is a pretty long module, and so the numbers are going to keep going for a little while. Okie doke. Let me unfreeze that. All right, so lesson 24, we're talking about, it says I can determine whether a whole number is a multiple of another number. Okay, so we are pulling in that fourth new word that I talked about last week. We talked about factors and prime numbers and composite numbers. Still going to talk about those. But today we're pulling in multiples because factors and multiples kind of work closely together. They're very similar, but different. And so we're going to talk about that as we keep going. We're going to get warmed up here with a few things. Okay. And believe it or not, this is going to help you with what we're doing today. So we're going to get warmed up with some skip counting. We're going to count forwards. We're going to count them backwards. Okay, so just let's stay together when we do this. We're not going to fly through this because you need to hear these numbers. Okay, it's not about speed. It's about really you learning these numbers, and it would be really nice if we could all do this without any trouble, without even looking at this, you know. But right now we're going to do this. A lot of us could do some of these without looking. A lot of us could do a lot of these without even thinking, okay? And hopefully we'll all get to that point eventually. Here we go. Y'all ready? Y'all awake? Okay, here we go. 2, 4, 8, 10, 12, 14, 16, 18, 20. 20, 18, 16, 14, 12, 10, 8, 6, 4, and 2. Okay, good. Let's do the threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Let's go back. 30, 27, 24, 21, 18, 15, 12, 9, 6, and 3. Okay, good. Fours. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. 40, 36, 32, 28, 24, 20, 16, 12, 8, 4. Good. All right, let's do the fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 50, 45, 40, 35, 30, 25, 20, 15, 10, and 5. Good. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 60, 54, 48, 42, 36, 30, 24, 18, 12, and 6. Okay, good job. Now, we just skip counted, right? Okay. Does anybody notice anything else about these groups of numbers? Okay. We know these are counting by twos, counting by threes, by fours, fives, and sixes. But do you notice anything else about? Just look at the numbers. Anything come to mind? Yeah.
You can multiply 2 times 2 to get 4.
Like I could multiply 2 times 2 to get 4. Okay. What else?
You can multiply every number to get every number in the answer. Like say 6 times 6 equals 36.
So you're saying if I multiply this by itself, it's somewhere, the answer is somewhere in the line. Okay. 5 times 5, 25. 4 times 4, 16. 3 times 3, 9. 2 times 2, 4. Okay. Anything else you notice about? And it could be anything. It's not a right or wrong answer right here. It's just wondering what you might notice. Yeah. I'm gonna have to get real close to you. What? The number's in the middle. What about the number in the middle? It's bigger. Okay. So the numbers get bigger as we go. They sure do. Okay. Anything else? Okay. Let's keep going for right now. Okay. This slide asks us to pull back some things that we've talked about last week. They want to know which numbers are prime and which of these numbers are composite. Okay. Prime or composite. So help us remember what those two things are. What is a prime number? What's special about it? What do we need to know? Prime number. Ishmael? Okay. It only has one and itself as its, what's that word? It was new last week too.
I forgot it.
Yeah. It's factors. Okay. Prime numbers, only two factors. And that would be one and itself. Yeah. Okay. What is a composite number then? A composite number would be the opposite of this. Okay, go ahead.
A composite is something that is more on paper.
Okay, more than two factors. And I don't know how readable that is, but maybe that will help us remember while we're talking about this. Prime number, only two factors, one in itself. A composite number, more than two factors. Let's look at the number 5. What do you know when it's multiplied together makes 5? Yeah.
5 times 1.
5 times 1. Anything else? Can we make 5 any other way with multiplication? Yeah.
5 times 2.
5 times 2 would be what?
10.
10. So that's not 5, is it? No. Okay. Can you think of one? Anybody else? Actually, 5 is prime. Okay. We'll put a P there for prime. Okay. What about 19? Let's think of 19's factors.
1 times 19.
1 times 19. Can we think of any others? And we could do our rainbow arcs.
2 times 9.
2 times 9 is it's actually 18. And think about what you just told me. Okay? Think about what you just told me. 2 times 9. Let's think about that for just a second. I'm glad you said that. Whatever 2 times 9 is, it has 2 for a factor, right? Yeah. And we said that 2 is a factor of every what kind of number? Even. So is 2 going to be a factor here? No. And so if you can remember little things like that, that might help you. Okay? All right, so this one is also prime because it doesn't have any other factors. Nothing else is going to make 19. What about 12? What about 12? Think about 12. Yeah. 4 times 3. What are some other ways we know to make 12? Yeah.
1 times 12.
1 times 12. Miranda, what were you going to say?
2 times 6.
2 times 6. You know, if you recognize, hey, that's even, then 2 is in there. We've just got to figure out what you multiply it by. Anything else that makes 12? Okay, and this is definitely easier to see when we do our arcs. But right now we're just thinking of our multiplication facts. So this number is either prime or composite. Which one?
Composite.
Definitely composite. It has more than 2 factors. Okay, the number 24. Prime or composite? Well, to figure that out, you need to know its factors. What is something that we multiply? Brandon, what's something that we multiply and we make 24?
1 times 24.
Sure, 1 times 24. We got to remember that one, don't we? 1 times 24, but are there others? That's the key question. Are there others? Yeah.
8 times 3.
8 times 3. Caleb, what were you going to say, or did he steal yours? He stole it. Yes.
2 times 12.
2 times 12. I'm glad somebody remembered the 12s. We're going to get those 12s. It just might take us a little bit. Faith?
6 times 4.
Yeah, 6 times 4. Okay. Any others? Okay, I think we've even, you know what, we could have stopped after that second one, and after that second one we would have known what? It's composite. It has more than 2 factors. Okay, what about 15? 15's odd. This has got to be prime. Yeah.
3 times 5.
3 times 5. Wait a minute now. You're going beyond 1 in itself. What else makes 15? What's the easiest one? What's the one we should start with?
1 times.
1 times 15. Now, are there any others with 15?
Wait.
Huh? Might be. Wait. There might be.
Oh, that's 16.
Okay. Even if there were a whole bunch more, what could we automatically know right now? That this is either this or this. Which one?
Prime.
It's
Composite.
It's composite because we're having Monday morning, and it's composite because it has more than 2 factors. Okay. All right. Good practice there. Let's keep going. We've got one more screen that we're going to look at. All right. I do want you to pull your board in front of you right now. Okay. We'll spend just a few minutes on this. We'll see how far we get. Okay. So up at the top, I don't want you to write these 4 numbers. Okay, you'll see why in just a minute. These 4 numbers are going to sit up here for us to look at. We've got a 30, a 45, a 48, and a 56. Okay. Now, we're going to try to answer these questions about these 4 numbers. So the first one says, write down the numbers that have 10 as a factor. Which of these numbers has 10 as a factor? You multiply something times 10 to get that number. All right, write that on your board. I'm going to ask you to show it to me. If it's 1, write it down. If it's more than 1, write all of them down out of these 4 that have 10 as a factor. Okay. All right, go ahead and show me. What do you got? Okay, I'm looking. Which of these numbers? This is what I need to see, either on your board, 30 or 45 or 48 or 56 or all of them or some of them. Okay. All right, so most of you, all right, you can put your boards down. Most of you have this number. Okay, and that is correct. That is correct. What do we know about a number that has 10 as a factor? What are we going to see in that number? Yeah? A 0. We're going to see a number in we're going to see a 0 in the 1's place. Okay? All right, look at the second one. Write the division equations. So these are math problems, division problems, that prove both 5 and 2 are factors of 30. You don't even have to solve the problems. I just want to see the math problems that are going to show me, you know, what if I wasn't sure that 5 was a factor of 30? Maybe I was trying to figure that out. What's the division problem you would write to figure that out? What if I didn't know if 2 was a factor of 30? What's the division problem? I want you to write those 2 division problems on your board. How would you write those? What would they look like? Think about on Friday when we were given a number and asked if something was a factor of it. We did something to kind of test it, to check it, to see. Okay, so you don't have to write words. I just need 2 math problems, 2 division equations. division problems would you write to see if if 5 or 2 was a division? To see if 5 or 2 was a factor of 30. All right, show me what you got. Okay, remember these are division problems. Okay, division problems. So 30 divided by 2, 30 divided by 5. Okay. 30 divided by 2, 30 divided by 5. You could have written it with the other symbol. A lot of you did that too. Both of those would show you if they came out evenly, if these two numbers were factors of 30. Okay? Is 2 a factor of 30?
Yes.
Okay. You can do the division to figure it out. Because 2 times this right here, I could do the long division. Let's do that. 2 divided into 30. 2 goes 1 time. We subtract it. Bring this down. It goes 5 times. Okay. Could you also figure out if 2 was a factor of 30 without doing the division?
Yes.
30 is what kind of number? Is it odd or even?
Even.
It's even. 2 is a factor of every even number. Okay, if we did 5 into 30, or 30 divided by 5, we cannot get a group of 5 out of 3. So we've got to look at it as a whole number. But think about your fact families.
Multiplication.
Think about your multiplication fact families. What do we know about 5 and 30? What number is missing? How many 5s can I get out of 30? Yeah, 6. Okay. 5 times 6 is 30, so we can subtract that and know it goes in there evenly. But could you have known that 5 was a factor of 30 without even doing all of that? Why? What do you remember? Okay, 5 is a factor of any number that ends in a 0 or a 5. Okay, so we talked about that last week too. Okay, let's just do 1 or 2 more of these. Write the numbers that have 6 as a factor. Now look, it could be more than one of these numbers. These are the numbers you're looking at. If you think 6 is one of the factors of any of these numbers, write these numbers down. That's all you've got to write. Now maybe you want to check. If you need to do some division to check, you know what to do. But write down any of these 4 numbers that you think 6 is a factor of. You might think it's just 1. You might think it's more than 1. All right, what numbers do we have? Tell me one of the numbers. Alexandra, what's one of your numbers? Okay, so you said 6. Anybody agree or disagree with her? Okay, I see a mixture of answers. A mixture of answers. 30 divided by 6. Okay, you have to look at that all together. We know 6 times 5 is 30. So yes, it definitely is a factor of 30. Any other numbers? Did anybody write down a different number on your board besides 30? I saw some. Don't be shy. Faith, what'd you put?
48.
You think 48. Anybody agree? Disagree? You also put down 48. Okay, I see some people agreeing. Nobody's disagreeing. Sometimes it's just we didn't think. Sometimes it's just that we didn't think that number would be. All right, is Faith correct?
Yes.
Okay. Can we do that evenly? Do you know something that multiplies by 6 to get 48? What?
8.
Yeah, 8 times 6 or 6 times 8 is 48. Okay, so this is 1. This is 1. This is one. Any others? Any others? Anybody tempted to say 56?
No.
You might have been tempted, but 6 times 9 is what? 6 times 9 is 54. It's very close to 56, but it's not. Okay, so we know 6 is a factor of those two numbers. Okay. Let's see. All right, some of that is more of the same. We're going to stop there for now and keep moving on into today's lesson. So, okay. Let's see. All right, we're going to follow along with these directions right here and do some of these to help guide us in our figuring out what a multiple is. Okay. So for the next few minutes, what I want you to do is you're going to turn to somebody and you're going to count by 4s. Okay. And you're going to take turns saying each new number. So if Gage was working with me and I said 4, then he would say the next number. Counting by 4s. What would be the next number? 8. And then I would say the next number, which would be 12. And then we would go back and forth until I asked you to stop. So your numbers might get kind of large. You may count on for a little while. Okay. So we're a little different today because of our absent folks. But if y'all would count with each other, you'll just turn in your seats. If you would count here, if you would turn around backwards and count here, if you would turn around backwards and count here. Okay. If you would count, wait, I can't do that. Let's see. You two would count with each other. You two would count with each other. And you two would count. So I know you might be going in a little odd direction, but okay, so you are in your seat. You're just turning your body. You're not moving your seat or anything. You're just turning your body. All right, so until I say stop, you're going to take turns counting by 4s. All right, so go ahead and start that.
16, 20, 24, 28, 32, 36, 44, 28, 52, 96, and 100. So now I have 102. 4, 8, 12, 16.
No, you're going. Oh, that's it. Yeah.
104, 102, 112, 116, 128, 132, 136, 148, 152, 106,
Okay, you're taking turns.
4 both segments.
Alright, so we're going to be done in 5, 4, 3, 2, and 1. Okay, so let's talk for just a second about what you just did. You turn back around. Anything that you notice as you count by 4s, and some of you might have counted by 4s way on up, beyond what you normally might stop at. Anything you notice? Any kind of patterns you heard or saw or... Okay, let's put the tops on our markers right here. Let them rest. What did you know?
They're all even numbers.
Okay. One of the things, when you count by 4s, no matter how high you go, they're all even numbers. Anything else you might have noticed? Think about the numbers that you counted and heard. Nobody noticed any patterns of any kind. Yeah, what do you think?
Every time you get to another 10, it starts a random pattern, and then to the other 10 it starts the pattern that you did first.
Do you remember what the pattern was, or?
Like 4A, and then it said 12, 16, and then 20, and then it started at 24, and then
So
it started counting backwards again.
So the number in the ones place was either a 4, an 8,
and then
a 2,
and then 6,
and then it was a 0, wasn't it?
And then 4A.
And then it would start over. Anybody else kind of catch that? 4, 8, 12, 16, 20,
And then
24, 28, 32, 36, 40, 44, 48, 42, 46, 50.
You said 48. Yeah, you said 40. 42.
Did I? 44.
44, 44.
I'm totally lost. 44, 48, 52, 56, 60.
60.
Okay. I might have been looking at that 8 while I was pointing down here. Okay. So something interesting is if you catch a pattern like that, it helps you continue to. You guys are flying.
Yeah, we were almost
Like
at
in their counting.
We were almost at 200.
And I think sometimes when you catch a pattern like that and you notice that it continually repeats, it helps you, doesn't it, know what comes next. Okay. All right. So lots of our numbers have patterns in so many different ways. But that's an interesting one about the 4s. All right, so what we're talking about is multiples, especially today. Let me open this up. Okay. What you did just now is that you counted multiples. Okay. You counted multiples. When we skip count, we are naming the multiples of whatever number we're skip counting by. This morning, when we first started and there was all those rows of numbers and we skip counted by 2s, by 3s, 4s, 5s, and 6s, we named multiples is what we were doing, as well as skip counting. Okay? Let's go back to that screen for just a second. These numbers are the multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and could we keep going? And going? And going?
Yes.
And going?
Yes.
You know, numbers are things that go on pretty much forever. Okay? So, could we keep going and going and going and going with these? Yes. Yes, we could. These are the multiples of 3. These are the multiples of 4. The multiples of 5 and 6. Okay? Everybody stand up by your desk for just a second. How many of you have ever been by a pond or a lake? Okay? You can raise your hand if you've been by. Okay. You put your hand down. How many of you have ever been shown how, or maybe you just did it, where you picked up a rock and you kind of side-armed it across the water and watched it skip across the water? Okay. And a lot of you have. And if you haven't, that's okay. So one way we remembered in years past that these are multiples and that you skip count to know the multiples is we would go, let that person pass the door first. Multiple. Because it's like we're jumping across the water. So y'all you have to have a very cheesy face to do it. You gotta kind of stay put this year, and we can't really travel. Okay? Very cheesy, very excited face. Ready? Because that's part of it. Ready? Okay, here we go. Multiple. Oh, come on. The more cheese, the better, because you're gonna remember what this is. All right. Just kind of try to. Okay. All right. Help me out. Here we go. Multiple. Oh, I gotta hear you too, though. I gotta hear you. That helps you have the big cheesy face. You ready? Multiple. Okay, because you're just so excited about it. See all the smiles in the room? This is great. Okay. So if I'm up here and I go, y'all know, skip counting, okay? Because we're like that little pebble
Wait, whenever we're skip counting,
going across the water.
Can we put our mouth
Doesn't matter. Doesn't matter. This goes with any number that we skip count by, okay? All right, so multiples are really just the numbers that you count when you skip count. Okay. Now, I want you to look at these numbers again. Okay. Do you notice anything about these numbers? Maybe now that we're a little more awake, maybe a little more alert. Is there anything that we didn't say already that now you might notice? Yeah.
On this side it's going 2, 3, 4, 5, 6, and then on the other end it's going 20, 30, 40, 50, 60.
Okay.
And then
Okay.
it's adding a 0.
Okay. That is interesting. I didn't notice that. Yes.
every time you multiply another number, it plus one, like 12 in 3 ways.
You're seeing something. There's no doubt in my mind you're seeing something. I'm just not. Keep thinking about how to put it into words, okay?
14, 15, 16. It's going like that. Wait, never mind. There's something.
That's okay. That's okay. Keep thinking. Really, not so much these all together, but what do you notice when you look down the line
Almost all of them.
of each one of them? Okay. Yeah.
On the 2s it goes 2, 4, 6, 8, and 10, and 2, and 2, and then 12, and then 4. And
Okay. That one's digit has a pattern to it, doesn't it? A lot of these do that. A lot of them have patterns like that. Anything else that you notice? Now, really, I'm talking about if you just took one of those groups of numbers. If I just grabbed, say, just this group. Anything you notice about those numbers? Yeah.
So, like 2, 4, and 6, they're all even numbers except 3 and 5 because they're odd.
2, 4, and 6. Are you looking here or up here?
So, like in 2, there's all even numbers, right?
Right.
On 4, there's all even numbers too.
Right.
In 6, there's all even numbers.
Okay.
But except on the 3, there's odd numbers. There's some even numbers, but there's odd numbers.
Okay, but there's a mixture, isn't there? Okay. 5. Same thing.
Yeah.
Same thing. Did y'all hear what he's saying? All of these have just even numbers. These two have a mixture. Interesting. Okay. All right. Here's something that nobody has mentioned that I want to say about multiples. Yes, multiples are skip counting, but they are also the answers to the multiplication problems when you do your math facts. And maybe you kind of already knew that. But this is 2 times 1. These are the answers. These are the products. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. You see that? Okay. 3 times 1. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. All right. Maybe you already realized that. Okay. We did mention this a while back. Same with the 4s, the 5s, the 6s. So, multiples are not just, hey, let's just skip count. They are. But they're skip counting because they are what you get when you multiply each of our numbers to that number. Okay? Alright, so multiples, you skip count by a number to get its multiples. So the multiples of 4, 4, 8, 12, 16, 20, 24, and so on. The multiples of 32. What? 32 is huge. Yeah. Sometimes we're going to be asked about multiples of really big numbers, not just our smaller multiplication facts. 32, 64, 96, 128. Okay? So that's what a multiple actually is. Let's go back where we were. It's not letting me do that, so let's do this. Okay. This bottom question says, how are factors and multiples different? So let's discuss that for a second. Let's actually go out where we have some room. So this is what you did on Friday in reading. This is not what we're doing right now. Do you think, let me ask you, do you think you will need this in class today?
No.
Because I can make this small.
Delete. Delete it. Be gone.
Okay, I don't see that happening real quick, so hold on.
Make it as small as possible. Uh-oh. It says Elizabeth Conley's
Yeah, I
MacBook
see that.
Air.
Honey. I see that. Oh, there we go.
Teacher powers.
Yeah.
Now that's big.
Oh,
Now
that's
small.
more.
Turn into an ant.
All right, well, let these guys go have their little party. Okay, so we're talking about.
Or just look like doors.
All right, so if Miss Elizabeth comes to this screen today and she's like, oh, "Where's my step?" Tell her just to go, zoop, and it's right over there. Okay, you just can't see it right now. All right, so we have factors, and we have multiples. And a lot of people get these mixed up because you're going to get questions like find the factors of such and such, or is this a factor? Is this a multiple of? What are the multiples of this number? And it's like, oh, which is which? So let's talk for a minute about how these two things are different, which is going to help us keep them straight and not get them mixed up. Okay? What are some things? We know factors a little bit better. We've been working with those a little bit longer. So is there something you know about factors that might not be so with multiples? Okay, because remember, this is how they are different. How they are different. Okay? Yeah.
Factors are how many, like, if you have a number, how many multiplication facts you can get out of it.
I agree.
Okay. So factors, let's see if I can think of a short way to write that. Factors, they're the numbers multiplied. I mean, just their definition shows their difference. Numbers multiplied together to get a product. But what did we say multiples are? They're not the numbers that are multiplied together. They are the product. They are the product. Okay? These are the products of factors. Okay? And we'll put that in parentheses. Skip counting. All right, here's a few differences, just a few things that I think will help you. Okay, so we might not be aware of these yet, but I want you to be aware of these. Okay. Remember how last week, I know y'all haven't learned alliteration yet in reading class, but we said it was kind of like Peter Piper picked a peck of pickled peppers, where you have that same
Wait, yeah, we did.
same sound.
Yeah, we did.
Well, y'all talked about that in here or in reading?
Reading.
Okay, great.
Because which one?
So if you hear that same letter sound repeatedly, it's called alliteration. And I gave you a phrase to go with factors. I said there were far fewer factors. Okay? Far fewer factors. Okay. But there's also an alliteration for multiples. Let's try and figure out what it's going to be. Hold on. A minute ago, y'all told me when we saw these lines of the 2s and the 3s and the 4s and the 5s and the 6s, y'all said we could go on. We could skip count forever. We could. So if there are far fewer factors, there are many more multiples. Okay? Many more multiples. If I said find the factors of, let's say, 15. I don't know if that's our best example, but sure, why not? Okay. Find the factors of 15. We've got 1 and 15. What else? We did this one already today. What else makes 15? We're not multiplying together. 1 times 15. Yeah, Bailey. 3 times 5. Are we done? Let's put the arcs there. These go together. These go together. How many factors of 15 are there?
2.
1, 2, 3, 4. There are 4 factors of 15.
Yeah.
There are only 4 factors of 15. That will not change. There are always going to be 4 factors of 15. But what if I said, all right, let's do the multiples of 15. Okay, now I know that we haven't learned our 15. But the clock helps us. 15. If we counted by 15, it's 30, 45, 60, 75, 90. Could I keep going on and on and on and on? Yes. Sometimes you'll, guys, sometimes you'll see the 3 little dots, which means it'll keep going. Okay. So when you skip count, you could go on forever. Think about a pond that never ends.
Gotta be an ocean.
All right. Far fewer factors, many more multiples. Another way to say this is that this is finite. I think we talked a little bit about that word. And that this is infinite. To infinity and
Beyond.
Okay, because it would keep going and keep going and keep going. Okay? All right, just some things that might help you remember the difference between these two things. These two things are very closely related, but they are different, so we got to keep them straight. All right. A few more questions here. Let's go back to our chart. That is not the right place. Hold on. There we go. Okay, some thinking questions here. All right, so it's a good Monday morning. Our brains are working good now. We've gotten good and warmed up. Here we go. Why is 24 a multiple of 4? Why is 24 a multiple of 4? When I count by 4s, am I going to land on 24?
Yes.
I will. Why does that happen? Why do I land on 24 when I count by 4s? Mason, go ahead.
Because if you skip count by 4 to 24, it would be one of the numbers, and it would be 6.
Because when I skip count by 4s, I'm going to count that number. And what else? What can you tell me about multiplication? What can you tell me about multiplication and 4s and 24?
4 times 6 equals 24.
When I multiply my numbers, 4 times this and 4 times this and 4 times 6 is going to get me 24. Okay, here we go. Here's another question. Is 24 a multiple of 5? When I skip count by 5s, am I going to land on 24? Will, you're over there going, mm-mm. Why are you shaking your head now?
Because 5 either ends in if it's a multiple of 5, it's either it ends in a 5 or a 0.
Okay, multiples of 5 are going to end in 5 or 0. That's how you know that 5 is a factor, but it's also how you know it's a multiple of 5. Okay? Is 24 a multiple of 8?
Yes.
When I count by 8s, am I going to land on 24?
Yes.
I am when I skip count, but what else? What can you tell me about multiplication with 8 and 24? Think about that. 8 and 24. It's like a fact family. What can you tell me? 8 times 3 is 24. So anything that you multiply by that number It's going to give you a product that you're going to land on when you skip count, isn't it? All right, is 96 a multiple of 3? Woo, we're getting large now, Miss Wendy. Okay, what do we do if we can't use mental math to figure it out? Okay, this is important because this is going to help you on your problem set and on down the road, not just today. If you are given two numbers like that and it says is 96 a multiple of 3, and you're like, whoa, what is the mental math? What is the math problem that you would write down on your board to figure that out? Yeah.
96 divided by 3.
Yeah, division is where it is what's going to help you. 96 divided by 3. Because what that's going to tell me, guys, is this. 3, is there something I can multiply by 3 to get 96? And if there is, then when I skip count, I'm going to land on that number. I'm going to land on 96. Okay, so I'm not sure. Let's do the division. You do the division right now on your board. This problem right here. Okay. Keep the answer to yourself. First question, how many 3's can I get out of 9? Caleb, how many 3's can I get out of 9?
32.
Well, how many 3's can I get out of 9? Start.
3.
3. Okay. And when I multiply those together, I get 9. And that's a 0.
Then you gotta bring down the 6.
How many 3's can I get out of 6?
2.
2. Okay. That is 6. So I'm going to have 0. No remainder, so it's even. Caleb's correct. 32 is the missing number we were looking for. So is 96 a multiple of 3? Yes. If it comes out even like that, when I multiply 3 times 32, I'm going to get to 96. That means I'm going to have to do my multiples all the way 32 times. That's a lot of skip counting. It's a lot of, some of you might have probably did count that many times a minute ago when you were doing your 4s with a partner. Okay. All right. So, on our there we go. On our problem set today, this is the kind of question you're going to see. You can go ahead and clear off, I'll tell you what, let's just do that so it's not a distraction. Clear off your board and go ahead and put it and your markers all the way away. And then we'll talk about this for a second.
That was fast.
This is not a super long lesson. It's a good introduction to multiples. Okay.
It seemed like it did. What is that?
Let me blow these up just a bit.
That seemed like it was easy.
Okay, so you are put away and ready to listen in 5, 4, 3, 2, and 1. All right, so I need your eyes. For each of the following, time yourself for 1 minute. See how many multiples you can write. Okay, that's a little hard to do when we're all working at different times. Okay, or in different paces. But write the multiples of 5 starting from 100. Okay? Write the multiples of 5 starting from 100. I don't think everybody in the room can see that clock. Hold on, let me try something.
Why don't you bring up a timer?
Because everybody's working at a different speed. Now, we might wind up doing all these together. Yeah, I think that's what we're going to have to do in just a second. Is I may set the timer and we just try it. But this is what I don't need to see. Somebody over here low.
Oh, I just said low battery.
Okay. So you're going to write the multiples of 5 starting from, wait a minute. Yes, you heard that right. Starting from 100, not up to 100. So you're going to start at 100. That's your first number. What would come after 100?
95. And then 90. And then 80.
Okay. Okay, why is that not working? 100. What would come next? 105. Remember, multiples. Your skip count. 105. What would come next?
110.
110. What would come next?
115.
You would go, well, if you did it according to their, if you do it according to their directions, you would go until the timer stopped. And just try to get as many as you could. Okay? Write the multiples of 4 starting from 20. Okay, Miranda, our books are closed right now. Write the multiples of 6 starting from 36. So we're going to give those a try in just a minute when we come back from our break. I'm just trying to show you some of the types of problems you will have. List the numbers that have 24 as a multiple. What numbers, when I skip count, I'm going to land on 24? That's what they mean. What numbers, when I skip count, I'm going to land on 24? Okay. Numbers that when you multiply them equal 24. Okay. So your factors are going to help you with this right here. Okay. Use mental math, division, or the associative property. Guys, I want to show you this right now while I've got your attention. The associative property is not a strategy that we have worked on in class. So when it mentions that, just kind of ignore that for now. That may come up later. We have not done that. So your two strategies are mental math or division. Is 12 a multiple of 4? When they ask it that way, what they mean is, when I skip count by 4s, do I land on 12? Okay. When I multiply 4 by a number, can I get 12? We know that. We know the answer to that. Okay. So what's going to go in the blank? A number? A yes? A no? What do you think? Look at the question. Is 12 a multiple of 4? How would you answer that? Yeah.
You would say yes.
You would say yes. Okay. So these are yes/no questions right here.
Yay.
Yes.
Okay. Can a prime number be a multiple of any other number except itself? Now that's a definite thought question that I'm going to let you think on for a little bit and try to answer. Okay, so let's take our break right now, and we will come back in just a second and get started on